Okay, and yes, this might be a good place for setters and getters, except that your UI by default can't interact with setters and getters, as far as I know. What I mean is the built-in Unity UI stuff. So when you're dealing with a game object and you're wanting something that can be changed, presumably through some sort of UI mechanic, like a zoom in, zoom out button, I don't believe getters and setters can be accessed directly. Whereas instead, public functions like this can be accessed through through the easy Unity UI system, just to make your life a little bit simpler. But that's that. Ethan says the only thing I understand here is that the double slash omits things from code. Yes, these are called comments. I know we're going a little bit fast, but we're trying to squeeze in a lot of stuff. That being said, there's very little code here, and already we are doing a pretty ridiculous amount of just stuff, right? Let's say we change. So our solar system, we generate one star and one planet every single time. We could randomize this with some random number of planets, especially if we went and created a new model, add new file called planet, right? Which is derived from orbital. We don't need the namespace in our particular examples. That's going to be fine. If we did that, and then we had something like generate. And what if we pass stuff like, I don't know, int, max moons, right? Maximum number of moons this planet is allowed to generate from. Public void, right? So what we do is randomize our values. So let's say we, set our orbital distance to some sort of number like random.range. Oh, using Unity engine. I want that version of random. So some sort of random.range from, let's say this is in millions. So from 5 to 1 billion kilometers. So we multiply this by, this is 3 million times 1,000 for making them into kilometers. So 5 to 1,000 million kilometers. This would be a good place to say that the, what's the time to orbit? Equals, let's just all set it to 365 days, because math is hard. Oh, this make Earth could be moved into the planet generation over here, for example. I'm just going to set this, but to do, in all caps, to do, because it highlights, fix with real physics. But there you go. All of our planets take 365 days to orbit. Makes no sense. Right, so you do that, and then you could even do something like our planet, our graphic ID. We're going to set it to a random.range from 1, not 0, because we're reserving that for a sun, to, I don't remember how many planets we've got, something like 12, like, to do. Make this not poop. Because that's pretty poop. But hey, we've got some variety in planets now. And then we can generate a certain number of moons. So we're going to say m is equal to random.range from 0 to max moons plus 1, because of the way that random.range works. So for to m, we are going to create a new moon. So which technically is the same as a planet in a way, although the distance is all off. I mean, it's like the random number generator needs to be fixed. I don't know, whatever. Let's just make an orbital called M, which is a new orbital, orbital. Spelling is hard. M dot orbital distance is equal to, let's just make it, I don't know, 1,000,000 meters. I know that makes no sense. That's 1,000,000. Fix me. This makes no sense, but that's okay. And time to orbit, we'll make it only take a month. So 30 days. And what are you complaining about here? Ah, yes. So let's make this be a planet, because otherwise you can't do that. And cannot explicitly convert from what? From int to ulong? Yes, you can. I'm sure you can. Well, you can't implicitly do it, but you can explicitly do it, and that's going to be okay. Boom. Oh, we already have M, so moon. Moon. There we go. So we're going to generate a certain amount of moons for our planets, which is going to be fine. And let's say our solar system will generate more than just one planet. So instead of make Earth, we're going to say generate. Nope. Generate. Thank you. So let's make every solar system have 8 planets, because everyone knows there's 8 planets in a solar system. Do this. We're not going to set a graphic ID. Do that. When we set up the moons, do we remember to add our child? No, we don't. This dot add child moon. So now if we did this, and we ran it again, our solar system should have 10 planets. Each planet will have an error because it's asking us for... This should give us an error here. I was going to say. Each planet can have 0 to 3 moons. Okay. Let's see what that does. What could possibly go wrong? There you go. We have a bunch of planets, and with moons, are they all... How come I can't... Oh, because you're the parent. Right. That makes sense. Oh, and you're over there. Yes! All right, excellent. Okay. Just zoom out a little bit more. Boom! We have our solar system. Now, obviously, the fact that everything is in a straight line is a little bit weird. Why is that? Well, they will orbit. If we were to go and update this properly, things would orbit. They would all take exactly 365 days to orbit the sun. You'd basically have a record player kind of a thing, right? Where the planets on the outside are basically zooming around real fast, and the ones on the inside are basically zooming around really slow, because it all takes them exactly the same amount of time to orbit around. But hey, we have this solar system with randomly generated planet graphics. Well, randomly selected from a list, I should say, right? With a random amount of distance over there. But it looks kind of dumb that they're all aligned the same vertically. Why are they all aligned the same vertically? Well, when we get the position of our orbital over here, right, we get our current position. We do the math based on our current angle. Our angle is basically set in the update, but our angle always starts at 0. Is that what we want? No. I think what we should do is have an initial angle that doesn't get changed. So this is like initial angle. It's like it's a salted angle. It's a randomized angle. It's some sort of initial angle value, which is going to differ from everyone else. So what we're just going to do is set this once. We're going to set a random.range that goes from 0 to pi times 2, right? Anywhere along a full circle. Oh yeah, and it'll be confused because both System and Unity Engine have a random. I want to use the Unity Engine's version of it. So we're going to set an initial angle, and then over here, when we figure out our actual position, we're just going to add that initial angle with our offset angle, which actually we could rename the angle one to offset, which might be a good idea. Offset angle. So now if we run this, everyone should start off with a random initial angle and then keep offsetting. Oh, apparently Oh, I didn't actually save. I didn't save everything. That's what went on there. There we are. So we've got our sun and we've got all our planets at a random angle around there. We want to do one more thing. So first thing is we can always change what solar system gets displayed because solar system view has show solar system over here. But what we need to do, because show solar system, you pass it an ID, and then it generates all the planets for that. But at no point do we clean it up. So first thing we have to do is first clean up the solar system by deleting any old graphics. And we can do that. If you delete something, deletes all the children? Yes, it does. Okay. So what we're going to do is our show solar system, before it goes through and generates all the sprites, which are all children of us, we're going to go and delete all of our old children. So while transform dot child count num children, the hell, it's not get child count anymore. What? Why am I going crazy? Child count in lowercase, but why is it not actually showing up? I guess because I got the capital C. There it is. Okay. Going slightly crazy, that's fine. While we have more than one child, what we're going to do is we're going to delete them. Now, destroying a game object is very simple. We simply call destroy based on, so let's say we get transform C for child equals transform dot child it's at index, get child at index 0. We're going to get the first child in C. We're going to say destroy the child's game object. Now, this will go and destroy all of our, well, not this. If we did a for each, it's very common to do like a for loop through all the children, destroying them one at a time. The problem with that is your children don't actually get destroyed until the end of the frame. So, and there's all sorts of issues why you've got problems and whatever. The cleanest way to do it is to do a loop while you have more than one child, grab that child, tell its game object it should be destroyed, but again, its game object doesn't get destroyed until the end of the frame. So it's very important that you take your child and you tell it that it has no parent anymore, which allows me to make my favorite joke, become Batman. Right, child, you don't have a parent. It's actually not entirely true because we're not killing the parent, we're killing the child, but anyway, we're telling the child that it doesn't have a parent anymore, destroying the game object. And what's important about this step is that as soon as this runs, our number of children goes down by 1. So we're just going to do this. So when we switch to a new solar system, we clean up all our existing children and then spawn a bunch of existing children. So now if we had some sort of GUI button to switch to another solar system, we could do that. So let's consider that. Our galaxy only creates how many? Our game controller creates 1 solar system. Let's, first of all, for the sake of argument, let's generate like 100 solar systems. This should still be really fast. Yeah, it should be fine. We're still showing the first solar system. Let's make a very, very simple sort of dummy GUI over here. Let's make a button. This will create a canvas for us and everything like that. We're going to make the first button is going to be called Solar 0. I'm going to take this thing, stick it in the bottom left corner, and what's going to happen when we click the button, we're going to make a new event for it. We're going to tell the solar system view that it should run its function called show solar system with a number, and it's going to be set to 0. Then I'm going to take this button, I'm going to duplicate it, take it and stick it to the right of the other one, and I'm going to change the label to solar 1. And when this button gets pushed, it's going to tell the solar system view to show solar system 1. So now if we hit play, and I can't move the camera, but that's okay. But I can do this over here. And we want to hide. How do I filter what layer gets shown? There's a place to set a filter so you don't see the GUI over here, and I don't remember where it is. Oh, wait, doesn't matter. We can switch back and forth between our two solar systems. Just like that, instantaneously. Deletes all the old graphics and draws the new ones. Boom. I think our main camera, we will go and zoom this out than just the camera itself, because I think that will lead to somewhat better thingies. There we go. So now we can switch between the two solar systems. Right? That works fine. Obviously, you'd want a better way to switch between solar systems, but that goes well. And I think the only thing we want to do now is to allow us to advance time. Shouldn't be gizmos. There's a way to filter the layer. Layer's in the top right. Oh, it's up here. Right, it's deceptive. It's not in the scene view. It's very, very confusing. It's over here. The layer's here. If you disable UI, because all your UI, right, the canvas here, if you look at the inspector, is on the UI layer. And it's over here in layers. If you turn off the UI there, it won't show up in your inspector view. Obviously, the user interface is still present in the game view, but then we don't have to worry about things being in the way over here. Kind of an odd, I don't know why the button's there instead of there, but whatever. Thank you guys for reminding me. I knew it existed. All right, so we can keep doing that. Now, one thing to note is every time we run this, our initial solar system is different, right? So it's, look at this. We got this cluster of 3 planets over here. If I close out, load again, no cluster over there. We got, every time we run it, we generate a new random system. If you don't want it to be different every time, one thing you can do before you start randomizing your system, we can set a seed for the random number generator so that it starts from the same place every time. So random dot, and for whatever reason, the Unity one is called init state. Well, you pass it a seed, and you can pass it any number. Let's pass it the number 18, 18, 18. There we go. That's the state here. If we run this every single time, our galaxy will be identical. So there you go. So this is Solar System 1 when your galaxy is generated with seed 18. If we close and restart, we should have the exact same planets in exactly the same place. Normally, the random number generator is seeded with literally the time that you start the program running at. That way, it's going to be a completely different scenario every single time you run. But you might want to have a fixed one. And the ability to share stuff is really cool. So, okay, we've got that. Last thing I want to do is I want to add a button to advance time, which is going to require us doing a few different things, but I think we'll be okay. So let's go, and I'm going to add a new bouton that says something like plus 1 day. That's how much we're going to advance time-wise by. We're going to advance it by 1 day. I'm going to go and stick this in the bottom right corner of the screen. So what we need in, say, our game controller over here is we're going to want a public function. Scaverat, hey, thank you very much for the resub. Random function that says something just like, I don't know, advance time. And it takes some amount of seconds. I don't know, that or something. Num seconds to advance by. And all it's going to do is it's going to instruct the galaxy. It's going to, I don't know, you know what we're going to do? We're going to say something like, we're going to track the galactic time, which is obviously going to start at 0. I could make it explicit, but it would start at 0. So when we advance time, what happens is galactic time gets increased by num seconds. And then our galaxy is told, well, it doesn't actually have an update routine, that's true. It would be all the children in there. Probably makes sense if we have some sort of update in here, but maybe we don't want to do that. Normally, you'd only want to update advance. Fuck it, let's just do it all. But you might want to consider the fact. So public void update uint. What did I call it in the others? Time since start. Consider only updating part of the galaxy if you have a crazy number of solar systems, because you might have like 1 billion, or you might, you know, maybe you want it procedurally generated that you could have whatever 1.8 quintillion stars or whatever it is, in which point you you'll want to only, you know, update some of them. Some of them may update in real time. Some may only update from time to time. There's all sorts of different possibilities like that. Really depends on what kind of game you're making and how big of a galaxy you are. But updating literally the entire galaxy worth of stars and planets and molecules and atoms would probably kill every computer. So, but what we're going to do here is we're not going to do that. We'll put it a little to-do. But instead what we're going to do is for... this is a good place for each. Fine, it's okay. For each orbital, I guess it's solar systems. for each solar system, SS in solar systems. We're going to call ss.update with the new time since start. And they will in turn update all of their children. So we don't run this every frame. We only run this when time advances. So our game controller, we can advance time by a certain amount, and then we're going to tell the galaxy that it should update to the new galactic time. The interesting thing about this is this also allows us to rewind time. I mean, in terms of the position of the planets, right? Because here we're advancing time, but is there any reason we couldn't rewind time by some amount? Is there any reason we couldn't do that? Absolutely not. I mean, we could just have change time, just, you know, allow a signed number. So maybe that's a better way to do it. Change time. We change time by a certain amount. This could be a negative number when we pass in here. Should be a long, and this should actually also be a U long. It's fine. Hey, Red! Thank you very much for the resub. Also, I missed a tip from Anonymous as well as Phobia1. Thank you very much, you too. I really enjoy all your streams and videos. Keep up the good work. Also, I would like to recommend a good beer to you, Optimator, made by Sputton. There's a slight chocolate note on the back end. I will look for it. I know I have not seen it before, though. All right, so we got that. We've got a bouton here. Really? All right, that's fine. But you can do this, right? You can't apply it between U-long and long. Really? Huh. All right, let's just have it called advanced time then. We could have a separate one for negatives, but there we go. That's interesting. You've got that. Okay, yes. So when your button gets hit, we're going to have a new event. You're going to let the game controller know that we are needing to advance time. Public void advance time. How come it's not in the list? Is it because you don't know how to deal with the U-long? Game controller. Yeah, it's not in the list. What if this were just an int? We'll probably get compile errors. Then would you be happy? Huh. Well, in this case, that's okay. So, calculator, seconds in a day. 24 times 60 times 60 is 86,400. 86400. So that's going to be okay, but is it going to allow me to do the math? I mean, probably if I force a, what you call it. Oh. Yeah, you're not happy with that. Now, I'm sure uint would be okay for there, but is it okay for here? You don't know how to deal with those. Okay, the int you're happy with in the button side, but not the compiling side. But that's okay, because I can force this to be treated as a uint. Even though if we get past the negative number, then things would be weird. I can sort of understand why you can't mix an unsigned one with a signed one in a sense. There we go. Okay, so now when we hit this button, we're going to advance time by 1 day. Now, this should just work, except for the visuals not updating. So if we do this, theoretically the universe is being updated every time I hit this button. But we're not seeing that. So what I would like to do is update the solar system view. Now, we could have this, you know, not necessarily update every single frame or whatever, but let's just have it update every frame. That's going to be okay. So what do we want to do? I think what we need to do is we need to have a map from our game objects. So what we want to do is loop through, yeah, so I already have the text there. So for, let's use a for each because I'm lazy. I don't know. Well, just like we have a make sprites for orbitals, we'll want something like a void update sprites for an orbital O. And what we need to do is say what my old sprite was. So I need a dictionary here, which maps So dictionary, that goes from an orbital to a game object. This is the orbital game object map. So every time we create a new solar system, we're going to reset this. And every time we make a sprite for an orbital, after it gets made, we have to make sure to update the game object map for the orbital to be equal to that game object, such that when we update the sprites here, we can get the game object from the map for O, and then we set GameObject.transform.position to be equal to the orbital's position divided by the zoom level. And then we still have to loop through each child of this orbital to update the sprite for those children. There you go, another little recursive little thing. And so in our update, we have to look at our current solar system, look at all the stars in the solar system, and update the sprites for those stars. Although the stars themselves, well, currently will not move, but that might happen. Okay, so every update, we're going to update our sprite's position. So this should just run fine by itself and not do anything. And then if I hit +1 day, our planets should, in theory, start to move around. Obviously, it will take 365 clicks to make the move, but if we look at these coordinates, oh, I don't think they're changing. So what step is failing? That is the question. Well, here's what we can do is we can compare the positions after I switch back and forth. Are they actually moving? I'm not sure. 7.4024. I don't think they're moving. I think we got to debug a little, but yes, you're right. I mean, I should actually run the actual debugger here, I think. Yeah. Let's put a debug command here. Hit play on the debugger. Hit play over here. Okay. And I can switch between the two. That's fine. If I hit this, it should load up the debugger. Yeah, we're definitely here with num seconds. Hop over. So galactic time should be updated. Non-public members. Galactic time is indeed bigger. So if we go into here, galaxy update. Oh, I jumped over it accidentally. Hang on. Come back over here. Hit +1 day again. Jump over. Go into this. For each solar system. How come it's not? There it is. Go into there. I mean, we should be good. Time since start, yep. We update the offset angle, then update all the children. All right, seems kind of okay to me. Stop the debugger. There's just something else going on that I'm not missing. The planets also update? Yeah, the update cascades down through all the children. It should anyway. So what I want to do this is the last thing we're doing. Like, I thought this would just work. So we need like 5 more minutes to figure out what this little tiny thing is. And what I want to do is I want to pull a placeholder. Yeah, maybe it's just too small of an update. That is entirely possible. Let's take the obvious thing. Instead of 1 day, let's update by 100 days. Although I would have thought it would work, but maybe, yeah, maybe it's too small to notice. No, it's definitely not. As far as I know, the numbers are all updating properly. So how could we tell? What I'm going to do in my solar system view is I'm going to name the object based on the angle. These numbers are changing too much. Like, way too much. So if we go back to just a day, so this is a day, these planet names, which are the angle in radians. There it is. Oh, wait, hold on. There's something off with my planets. How come they're stuck at 0? Yeah, the angle in radians should be very small, and everything else should... Let's skip the moons. A second here. Yeah, their angle's not changing, and the sun is going bonkers. Okay, the sun is going bonkers because that's okay, because I say that it orbits once every second, so that's fine. This is not quite right. It's fine for the sun, but not for the planet. Well, it might not, it's clearly not fine for the sun either, but okay, I'm going to hit this. So first one we're going to do is the sun itself, right? How come you're not giving me some information here? Oh, because I'm not debugging. Hit this button again. There we go. Now we're debugging. So this is going to be the sun. Oh, don't debug that anymore. Yeah, this is a solar system. Offset angle is kind of meaningless for that. So I'm just going to hit play. Because now I'm on an orbital. This should be one of our planets, which has an init angle of that. The offset angle is hugely massive. For what reason? My time to orbit is set to 1. Why is my time to orbit set to 1? It gets set here, but not really. This is one of our planets. Okay, yeah, that's something that's kind of confusing me a little. Some of my planets have the sun graphic as well, which they should never have. So there's something in our generation code. When we create our solar system, we're generating something wrong. Planet.generate. And put a little break in here. Keep debugging. Stop, play. And it's right here. My planet base, graphic ID 3, initial angle. Yes, that's good. But then why is our solar system all shitty looking? So that planet makes sense, but then... No, I guess that's all reasonable. Time since start / time to orbit should be smaller than 1. It's a very... There's a little math thing going on here. Oh, is it because they're integers first, and we're ending up with too small of a number for a little while? I bet you that's it. I bet you it's like integer math bullshit. Let's change this around to 2 times... Make sure it's a floating point number. Times this. Let's do everything as a float. Like this. And then divide by the integer component. And see what that does for us. Hey, there we go. There we go. It's because we were doing dividing one integer by another, and they were still doing it as an integer, so it was just any number below 0 was just getting clipped, floored to 0. Whereas here, I mean, we didn't have to write it this way. I could have just cast things. Let's say I undo here, and we go back to the way it was written before. But make this a float and force this to be a float. I think we only need one. This should also result in things working properly. Because now the division will result in a float, which can represent a number below 0. And then we're orbiting around! Again, things are off because literally everything is orbiting once every 365 days, which is not correct. But I will leave that up to you to complete that equation so that the orbits are realistic based on their distance from the sun. But we still have the ability. And what's interesting here is, all right, note that this planet is sort of vertical, slightly to the right. Okay, this planet over here. I'm going to go back to Solar System 1 in advanced time over here. And then go back over here. There, see how it's turned? Even though we weren't looking at the solar system, all this got updated as well. So all the solar systems are being updated in real time when we do this, but we're only looking at one, and we can switch between the ones that we view. And obviously, you can come up with a better user interface for cycling between solar systems. Okay. All right. Now enable moons. Oh, yes, let's re-enable the moons. Our planet generation over here. Let's do this, do that. So now... the big problem, though, is that the moons, of course, are not very far from the planets. Therefore, there will be a little bit squooshed up on things. But if I zoom in on one of these planets here, you have 3 moons. Oh, there we go. Or maybe the moons are too far away. Where is your moon? Oh, no, I guess... Oh. The moons are all squished onto the sun. Yes. There is a problem. Because we are not considering our parent over here. So this vector represents our offset from our parent. So what we need to do is something like this. Vector 3, my offset from my parent, right, is this. And we were just returning that. But that's not accurate because what we need to do is if parent not equals null, then, well, let's rename this to my offset. My offset. Then what we need to do is my offset needs to include my parent's position, which will include their parent's position and whatever, because they're all orbital, so they'll go down the chain. So now our moons will be properly attached to our planets as opposed to using the sun's position. So if we find a planet, so this planet here has 3 moons, and if I click, you see that my position on the screen doesn't move, and I can't, I can't shift things. I could hide your sprite renderer. Now I can see the moons. And if I do this, I can see the moons underneath it. But the moons have such microscopic distance from the parent that they're going to overlap. Because we don't do proper zoom level scaling and things like that, the moons sort of are invisible because they're distant from the parent. But they are there. They are there, and they are, you can see their values are changing relative to the parent here. I think the moons are ending up with the tiny microscopic rotation time as well, because when we generate the moons, we set a time to orbit, we set an orbital distance. We're fine. I'm pretty sure it's working. It's mostly working. We got as far as I want to get. I kind of want to do more stuff because this is kind of a cool project. Oh. Something ain't quite right. Because the moon should still be linked. Is it just the moon is too close? Let's say, like, I'm just going to drop this down to, like, almost but not quite 1. So the moon should be 100% stuck to the planets. What is this one? Not naming things makes things a little bit trickier. You're a planet without a moon. And you're moving slower than the others. Like, everything should still be orbiting the sun at exactly 365 days. They're adding their stuff too much. It's moon time to orbit. Thank you very much. I'm going to say, the orbit time of the planet was getting changed. So there you go. So now we set the moon's time to orbit properly. That explains why that number was so huge as well. There we go. Now everything's back in the correct way of all orbiting at the same speed. And the moons now correctly are orbiting once every day. That explains why the numbers were getting so big. Or once every month. So every time I click here, the angle should be going up, yeah, by something pi. Okay. It's still incorrect that everything's orbiting at the same speed, but that's not a code error per se. That is this over here. No, sorry. This over here. Well, this too, actually. Make this non-poop. Fix with real physics, right here. Fix with real physics. Fix with real physics. So we need some sort of function that's like a void, or sorry, it needs to be a u long orbit time for distance. And I mean, maybe time to orbit should just be like always dynamically generated, but we could, for the sake of argument, I'll do this. So like, fix me, make real math. And for now, what we'll just do is we'll return the 1 year, which is fixed, like that. And so over here, moon dot orbit time per distance. Which this needs to be part of the orbital layer. We'll fix that in a second. And this dot orbit time per distance. So this isn't part of planet. This is part of an orbital. Like that. There we go. So that's a place for you guys to introduce the proper formula. Oh, protected. What are you talking about? It's part of orbital. It's part of orbital. Oh, because now, oh, because I see. Yeah, no, yeah, all right. Yeah. There you go. Needs to be fixed right later on, but for now it's okay. All right, we're going to wrap this up. If you guys have any questions, technically the planet's moving around the sun the wrong way. Should be anti-clockwise. Well, if you're in our solar system, right? Because in our solar system, you're right. Everything goes anti-clockwise. So then the question is, what is the fix? Are we going to be adding negative radians? Are we going to be inverting the sign, like the mathf.sign function that uses to calculate the x-coordinates? Any of those would work. So we can choose how we want to go and wrap around. That's fine. But like what I'm saying, we could do it as simple as over here, it should be maybe the negative from the cosine. Or we want to do change the angle, the way we add angle based on calculations. And maybe our planets aren't supposed to go in this direction. Every solar system can orbit in a different angle depending on how you define top, although I guess we define top that way. So there you go. So that's one way of fixing it, just by inverting that sign over there. We'll have to figure out what, how you guys want to set it up. And hey, there's another Tipsplosion. Again, we're going to wrap up the programming here. If anyone's got any more questions about the programming, please shoot them my way right now before we go and play some Kerbal. Hey, Weimerway, thank you very much for the tip. Been watching your YouTube channel for a year now. Finally caught a stream when I actually had some money to send for some lovely chocolates. Can't do whiskey due to the U.S. alcohol laws. Also, the Canadian laws cannot ship most booze through the mail, which is very annoying. But I will definitely put it to some chocolate. Thank you very much. Very stars. North is defined by which side appears to move counterclockwise. Oh, I guess that would be a good way of defining it. Yeah, sure. I like it. Excellent. Bum, 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 bum. And it would be very, 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 very rare and extraordinarily unlikely to have one planet that orbits in a different direction from how all the other orbit. Because normally the solar systems coalesce as a single rotating gas cloud. So everything that comes out of it should all be rotating or orbiting the same way. All right. So we're going to wrap that up. We're going to play some Kerbal Space Program. We're going to try to make a base on the moon. Or no, in orbit of the moon. We're making a space station in orbit of the moon. Without mods, which is going to be very tricky. You want to see the moon orbit around the planet? I mean, technically they're there. It's just so small you can't tell. How could I do it? Well, if I went and rescaled the sprites or did something like... They're there. I guess I could increase the distance at which the moons are spawned. That would help if you really want to be able to see it. All right, because I set the orbital distance to like microscopic. If I do this, I don't want to go too far. Compile, compile, compile. How's that? Do we have visible moons yet? Nope. Right, because this is in meters. Let's add a couple more zeros in there. It's displacing a little, but not quite yet. There we go. Now we can see moons. So now if we do this, and it's a little hard to tell, but the moons are definitely... Oh, right, they're hard-coded to 365 now. Divide by 10. Shh. Shh. And yes, the real physics calculation is really easy, but there we are. We have moons that orbit their parent planet. Then you want to do things like scale things maybe based on a parent size of the body, as well as the sort of camera tricks so that when you zoom in and out, things sort of stop at a certain point size. Pretty orbital dance. The distances are all insane, but it's working. Cool. All right. Kerbal Space Program. We're going to take a short break. I'm going to load up the new game, and I will catch you guys on the flip side. If you did miss any of the programming, it will be over at youtube.com/Quill18Creates, which is my programming channel, where I do Unity tutorials and C# tutorials and things like that. That is sponsored, promoted. No, none of those things. Supported by the lovely people over at my Patreon, patreon.com/Quill18Creates, who support the programming tutorials, and it's because of them that we do one of these every month. So, be back in a couple with Kerbal Space Program. Thank you to all our August patrons, i.e. people who pledged in August and who are supporting videos from September through to early October. And especially these Mic Check supporters. We got Ole Peter Talgo, Adam Conway, Drazion, Jan Vel, Adjective, Michael McClintock, Aaron Toyson, Craig Mortel, Julian Auger-Lafont, Marius Fieldvold, Speedy Savant, Steven Stager, Valiant Cake Fiend, Wes Oldenboiving, Jason Yanity, Kale the Quick, Neil Blakey Milner, and Yukofin, and everyone who's watched, shared, favorited, and subscribed. Thanks for watching. See you next time.